Okay, so what we're going to do today is we're going to talk about both the project, and I want to kind of give an intro into what statistics is about. So what we're going to do is actually do the intro first, and then I'll talk about the project. If you go online onto Blackboard, though, you will find the project outline or project requirements. So if you want to go there at some point, you can go ahead and do that and be prepared for that. So what is statistics? That's the key question. Some people would say it's something that just is trying to be here to annoy students, confuse them, and get them all upset. But what statistics is, and I'm going to give a basic definition. Statistics statistics is the study of variation and how we can manage, reduce, and predict this variation. And the idea is that nothing, unless if you're into physics with two things collide at this angle and this is what happens, or in chemistry, if you mix these two chemicals, this reaction will occur. Nothing in the real world is typically given, and this will absolutely exactly happen, especially anytime you're dealing with human nature. And so what we can think about with statistics is that I can ask you the question, how long does it take you to drive in from where you live to campus in the morning? And you can give me an answer. So you could say it takes me 20 minutes. Okay? And I completely believe you. I think that that's fairly accurate. But if I asked you every day till when you got into your car and fired it up in the morning and start driving to start a stopwatch, and then when you got onto campus and found a parking space to stop that stopwatch, what you'd find is that most days it would be average around 20. But one day might take you 18 minutes, another day might take you 22 minutes. One day you get on the beltway and you're behind someone in the left-hand lane who's going 60 miles per hour. Kind of happened this morning. And things like that. Or sometimes you come onto campus, you immediately find a parking space. For those of you at 8 o'clock, it's not as bad. But if you come at 11 o'clock, sometimes it takes students 10, 15 minutes to find a parking space. Sometimes you find one right away. But that's what we mean by variation. The idea of how long it takes you to drive, you have a good idea about how long it takes you to drive. But it does vary in the morning. You don't know if you're going to hit a traffic light or something like that. That's what we're talking about with variation. Okay? The variation's all around us. And basically anything with human nature involves variation. Yeah. I've often thought about, for example, students who take the SATs that get upset or get really excited based upon their score. Well, some of that just depends upon what were the words that morning on the vocabulary. Were they words that you studied or didn't study when you were preparing for the SATs? So that's what we're trying to study here, this idea of variation. And how can we understand, is this variation something that is predictable in terms of, I know, for example, I'm teaching an 8 o'clock class. I usually come in a little bit after 7 o'clock here on campus. And my drive time is pretty consistent. It takes me about 20, 25 minutes to go on campus. Well, I was teaching one semester at 9:30. it always took me longer in terms of the beltway normally would be more crowded. And some mornings I'd get in fine and it'd take me 25, 30 minutes. Some mornings it would take an hour because if there's an accident on the beltway or something of that nature, it just would take me a lot longer. Where if I come a little earlier, I usually avoid that traffic. So that could be a way of reducing the variation in drive time. Predicting it, it could be a little bit of kind of the question that I asked you on your midterm exam about I-83 being jammed based upon whether it was sunny, cloudy, or rainy outside. Okay. So maybe we could try to talk about how does the weather affect how long it takes you to drive to campus. We could think about maybe houses. Okay. You go into a neighborhood, maybe a more established neighborhood. Why do the prices of houses vary? Okay. Well, you'd say, well, some houses are newer than others. Okay. Well, that's true. Some houses are bigger than others. Well, that's part of it. Okay. But how much does your house being bigger matter to your selling price? Okay. How much does the age of your house vary? Yeah. Where I live, my house is right next to a house that looks pretty much similar. It's very similar. Yeah. We've finished our basement. I know our neighbors haven't finished their basement. How much does that increase the selling price of our house relative to theirs? They have a much larger deck on the back of their house than ours. You know, how does that affect their value? So we could talk about those types of issues and try to figure out what is causing some of that variation. So that's what we want to do in this class. That's what statistics is about. It's about figuring out that variation that is out there in the real world on a day-to-day basis. Any questions so far? So there are two branches of statistics. The first branch is descriptive statistics, and this is the one that everyone knows. This is taking a data set and describing the characteristics of that data set. So telling me what is the average, what is the standard deviation, what's the minimum and maximum, what's the first and third quartiles, what's the level of skewness in your data. All of those are descriptive statistics, and they clearly have a role in what we're doing in this class. That you need to be able to take a data set and be able to describe the characteristics of the data set. And that's what descriptive statistics is. However, it's the one that we're going to spend the least amount of time on. We're actually going to just spend one lecture dealing with descriptive statistics. Where we're going to spend most of our time in is the second part, which is inferential statistics. What inferential statistics is about is taking a data set and drawing conclusions from that data set. Okay. So it's about, for example, taking housing prices here in Baltimore. Okay. So you go into some neighborhoods, get the prices of the houses that have sold, get information about those houses, how many bedrooms, how many bathrooms, how large is the house, how old is the house, what type of amenities does the house have, and taking that data, and we can do descriptive statistics. So you can tell me the average house in Baltimore sold for $300,000. The average house had 2.7 bedrooms and 2.1 bathrooms and is 20 years old or something like that. So you could do all that descriptive statistics, and that tells me a lot of information. But what I want to do is I want to be able to draw conclusions. Have housing prices dropped? So I could go and look and say, 5 years ago, the average selling price of a house was, sold in Baltimore for